The problem-solving strategy, y equals f for x. The most important aspects of the Six Sigma approach to problem-solving is the concept of y equals f for x. It will be critical that you understand this concept. The entire Six Sigma problem-solving can be summarized with this general-purpose breakthrough equation. It is depicted as y equals f for x plus epsilon, where y is outcomes, or results you desire, or need. X represents the independent input variables, or factors, or pieces, necessary to create the outcomes. You may have several input variables xs, like x1, x2, x3, and so on. F is the function to express the way these inputs are transformed into outcomes. Epsilon represents the error, or the uncertainty, surrounding how accurately the x's are transformed to create the outcome. Thus, the equation comes like this: y equals f for x plus epsilon. Let us take one example. If you want to prepare loaf of bread, you take wheat flour, yeast, salt, sugar and other ingredients. Then, you prepare a dough and bake it to get the desired results. Here, the ingredients and oven settings are the input xs. Kneading and baking are the transforming process, or function f. And the resulting yummy bread is the y. The extra error, epsilon, is the factors you don't account for. It can be humidity in the atmosphere, or the freshness of flour, etc. Let us take another example. There is a fast food company that wants to measure their delivery credentials. They claim that food shall be delivered by 30 minutes time from the order receipt. Presently, 20 out of 50 deliveries are on time, that is, within 30 minutes of receiving the order. Now they want to achieve 40 out of 50 deliveries to be on time in next 7 days' time. This is an output measure and is called y, the dependent variable. Here the challenge is to reduce the delivery time below 30 minutes. Now the delivery time depends on various factors. Process time for preparation, TP. Distance between the shop and customers, D. Billing time, TB. Amount of time lost in traffic jam, in peak hours or in non-peak hours, T. Condition of the vehicle used by the delivery person, VC. Skill of the delivery person riding a bike, etc. S. Now these aspects affect the delivery time differently, and we have understand and measure their degree of contribution in the overall delivery time. The process time directly affects the delivery time. The distance integrates with the average speed of the delivery vehicle. Whether the delivery location is in single cottage or in high-rise. Whether it is with or without a lift. Amount of time lost in traffic jam can be differently affecting. As delay can be different for same waiting time in signal in differently busy roads or at different times of the day. If required delivery time is y, then this can be expressed as y equals a function of process time, TP, plus function of distance, D, plus function of billing time, T, B, plus function of time lost in traffic jam, T, plus function of the condition of the vehicle used by the delivery person, V, C, plus function of his or her skill, S, etc. This problem-solving methodology takes you through the process of determination to identify all potential excess that influence on-time deliveries, and then determining through measurements and analysis which excess are significant. Those will become the excess that are used in the y equals f for x equation. As a result of this exercise, this problem-solving strategy ensures that our food delivery company does not spend $1 million on a GPS system for its delivery vehicles when the root cause of the problem is not actually directions.
End of the session.
To make the learning even more engaging, our research team has prepared a short quiz for you to test your understanding. You can find the link to the quiz in the description below. Take a few minutes to complete it and feel free to share it with your colleagues, friends and online mates. Before you go, don't forget to hit the bell icon. If you haven't subscribed yet, now's the time. Don't miss out on the latest insights. I look forward to seeing you in the next video.